Hello, my name is Walter Wimberly, and I'm an assistant professor of computer science. Today I'm answering questions that a lot of new people to computer science, or maybe people who aren't real familiar with computer science, might be having. The question today is, what is an algorithm? Now, I'm getting that question a lot more frequently because a lot of news surrounding and using the term algorithm. And in a lot of cases, people are not using it correctly in the news. So what is an algorithm? Well, an algorithm is very simply a series of steps that we're going to take in order to solve a problem. That's all an algorithm is. So an algorithm can be very, very simple or quite complex depending upon what it's trying to do. Let's take, for example, the Pythagorean theorem and create an algorithm to solve that. Now, your Pythagorean theorem is something you probably learned in high school, either a algebra or geometry type of class. That theorem is used to determine the length of a long side of a right triangle, assuming you know the lengths of the two other sides. If I was to build an algorithm for it, it would be quite simply. I'd take my first small side and I would square it. I'd take my second small side and I'd square it, add those two numbers together, take the square root, and that is my answer. It's a series, just a couple of quick steps in order to solve that problem. Where things get a lot more complicated is when I'm solving more and more complicated questions, like should I hire applicant A or applicant B? And I use a computer tool to sort through all the information about these two individual applicants and determine which one should be admitted to grad school, or maybe which one should be given a job opportunity with a company. And now it has to look at a lot more pieces of information and has to make some intelligent guesses based upon that algorithm, and it's going to use weighting scores and different things like that. And that algorithm may be pages and pages long to explain what it does, and even longer in computer code. Now, we're not going to talk about that type of algorithm and how it might work. Now, sometimes there's more than one way to solve a given problem. Let's say I had some set of data, maybe a list of names. I want to put them in order. Well, I have more than one way to sort this data. Now, which one I pick will depend on several factors. Now, some are easy to code and they're really easy to understand, and that'd be like the bubble sort, but it's also really inefficient. And it will take a long time in order to go through and sort that set of data. Now, if I only have 10 elements, it's not that big a deal, and maybe I use the bubble sort because it's really fast to write. And if I know I only have 10 elements, the amount of time I'm going to save is going to be very, very small. But if I have 100 million elements, let's say I'm listing every school-aged child in the United States, okay, now I have a lot of data, and the bubble sort would be horrible. So I'll spend more time and more complexity in writing the algorithm and the code and come up with something like a quick sort. And that's going to be much, much faster for me. And so the speed of writing and the use of the computer programmer's time versus the speed of writing and the use of the computer time will depend upon which one I'll pick. Sometimes my algorithms will use a lot of extra memory to be a little bit more efficient in runtime. Or maybe I'll use less memory but take more time in programming because I'm at my memory limits, but I have lots of processing power. All these things really matter when we're trying to pick which algorithm to use in a given circumstance. So if you're wondering what an algorithm is, just remember it's a series of steps to solve a problem. How we solve it will depend upon a lot of outside factors.